So far in this chapter, we've been talking about polynomials and a lot about the graphing of the polynomial functions. But now we're going to be talking about it algebraically, specifically dividing polynomials. And I'm going to show you two different ways. It's long division and then the synthetic division. So just a refresher on long division. So here's an example, 38 divided by 7. So when I take 38 divided by 7, it goes in there 5 times. And then we have a remainder of 3, and so literally this would be 3/7. You take your remainder and put it over your divisor. Now 5 and 3/7, we always say 5 and 3/7, so that literally means 5 plus 3/7. And that's how a mixed number is, there's like an invisible plus sign in between a mixed number. Even 2.5 means 2 plus 1/2. That's literally what it means. So you're adding that remainder to it. So that leads us to the division algorithm. And this may look like really big fancy, but it's really the stuff you've been doing since elementary school. So here you have a polynomial divided by another polynomial, and what's going to end up happening is you're going to have the quotient that's going to end up happening, and then you have a remainder less left over. Remember, the remainder is, this is the remainder, but it's being put over the divisor. And so that's really what you have, is the remainder over the divisor. The quotient is the answer to the division. So 5 would be the quotient, and then the remainder over the divisor. So again, this is a polynomial division, and this is the division algorithm, it just in more algebraic terms. All right, so let's look at our first one where we have a trinomial divided by x minus 4. So this is long division. So here we have 6x squared minus 26x plus 12. And we're going to divide it by x minus 4. Now, normally with division, what we do, especially when you have a binomial here, we're going to specifically look at the first term. And then we're going to find out, like a normal division problem, we even going back to the previous problem that we did, how did we come up with 5? Well, 5, we multiplied 5 times 7, because it goes into 38. So that's what we're doing, is we're going to find some number here that we're going to multiply by x, the first term. That's going to give us 6x squared. So this right here is going to give me 6x, because 6x times x is 6x squared. So now, once I find that number, 6x, I'm going to literally use the distributive property. So 6x times x is 6x squared, and 6x times negative 4 is negative 24x. Now, here's the part that you got to be careful with. Remember on division, when we do this, even going back to this problem right here, we put a subtraction sign, and then we subtract them. Well, be careful when you subtract this. Make sure that you include, it's kind of like the distributive property. Make sure you subtract both terms. So 6x squared minus 6x squared, these cross out. Negative 26 subtract negative 24 is negative 2x. And remember, the next step of division, you bring down the next digit or next term, and then you go through the process again. So you ask yourself up here, what times that first number, x, is going to give you negative 2x, and that's negative 2. And then once you find that, you're going to multiply it by this whole entire thing using the distributive property. So that's negative 2x plus 8. And again, I want to caution you, make sure you subtract and use the distributive property. So negative 2 minus a negative 2, these cross out. They should always cross out. And then 12 minus 8 is 4. So I have a remainder of 4. And so what we're going to do is write plus 4 over the divisor, x minus 4. So when I divide 6x squared minus 26x plus 12, and I divide that by x minus 4, the answer is 6x minus 2 plus 4 over x minus 4. That's how you're dividing long division. Let's try another example, a little bit bigger. But here you have something. Notice, I want you to notice something. We have x to the 4th and then x squared and then x. Notice it skips from x to the 4th to x squared, and there's no x cubed. You'll see this in a minute, but every term has to be kind of accounted for. So there is no x cubed, so I'm going to literally add a 0x cubed. Notice 0x cubed does not change the value of it. So don't add a 1x cubed because that changes the whole polynomial. 0x cubed does not change it. And you'll see why I'm adding, it's really a place value is what I'm doing. And you'll see it once I start dividing. All right, so here we have the problem, and you're going to go through this process again and asking yourself, you're going to look at the first term, and you're asking yourself, what do I need up here to multiply by 2x squared that gives me 8x to the 4? Well, that's going to be 4x squared. Now, once you find that, then you're going to distribute the entire trinomial. So 4x squared times 2x squared is 8x to the 4th. These should always match. And then use the distributive property again. So 4x squared times negative x is negative 4x cubed. Notice these line up. That's why I put the 0x cubed, is so that you have a place value of the x cubes. Some books or teachers may just say leave a space, but it's the same idea to be able to do that. And then finally, 4x squared times 2 is 8x squared. So notice the x to the 4th line up, the x cubed line up, and the x squareds line up. And again, I want to caution you, I'm going to say this every time, but caution you to make sure when you subtract, I would suggest you put parentheses and use the distributive property. So these are going to cross out. 0 minus a negative, that's positive 4x cubed. And then 6 minus 8, that's negative 2x squared. And then we're going to bring down the next number, and we're going to continue on with the problem. So we ask ourselves up here, what times 2x squared is going to give me 4x cubed, and that's going to give me 2x. And then once I find that, I'm going to use the distributive property with this whole entire trinomial. So 2x times 2x squared is 4x cubed. 2x times negative x is negative 2x squared. And then 2x times 2 is 4x. And again, just notice these should always line up, x cubed, x squared, x. And then again, put parentheses and be careful with the subtraction sign. So 4x cubed minus 4x cubed, these cross out. Negative 2 minus a negative 2, x is plus, so these literally cross out as well. And then negative 3 minus 4 is negative 7x. I'm going to bring down the plus 1. And then what we're going to do from here, because the answer that you have left over, this is to the first degree, and the divisor up here is x squared. We can't actually divide anymore. So this is sort of this is what's left over as your remainder. So if I divide that, I have 4x squared plus 2x, and then I literally have the remainder of negative 7x to the first plus 1. And left over to the side. And remember, this is divided by the quotient here. So if I rewrote the entire thing, so this is what, when I take that blue polynomial divided by the other polynomial at the very beginning, this is what your final answer will look like, because you're multiplying or you're dividing the polynomials, and what's left over is you have the quotient and then the remainder over to the side. All right, so let's look at a long division problem and compare that to something called synthetic division. You should remember you've done synthetic division in the past. So let's look at this and go through the process again. So if I had this problem, again, I'm going to do this problem kind of quick because I'm going to switch over from long division to synthetic division to be able to do this. So again, you're going to find 2x squared right up here. And then once you find that, you're going to distribute that. So that's going to give me 2x cubed minus 6x squared, and then emphasis of subtracting. And you're going to end up getting negative 1x squared, bring down the 0x. And then notice, to continue on, this is going to be minus x, and negative x times x is negative 1x squared, and then negative or positive 3x. And then subtract. These will always cross out, and you're left with negative 3x, and then bring down plus 5. And then finally, we're going to get negative 3, and that's going to give me negative 3x. plus 9. When I subtract, you're going to end up with getting negative 4. Now, once I've done that, I'm done with long division. So let me remind you how to do synthetic division. Synthetic is just a short way to do the division, but we're just going to pay attention to all the numbers because, you know, if you look back at this problem, I'm writing a bunch of X's everywhere. And really what I'm really emphasizing on is just, if you look at just the numbers themselves, you know, the numbers themselves is what really is going to end up being to do the math behind it. And the variables, the X's are there, you know, to keep the place value, but you're going to end up with the same answer using synthetic. So notice if, just to make sure you understand, if X minus 3 is a 0, then we would, you know, normally add 3, and then X equals 3. So that's what we normally do. And so we know if X minus 3 is a 0, is a factor, then we know X equals 3 is a 0 of that. So what we're going to do is end up using synthetic division, but we're going to use 3 as, because it's X minus 3 for the divising, we're going to actually use 3 as the number to use synthetic. And again, all you're going to do is pay attention to the numbers. So 2, negative 7, 0, and 5. And again, notice I have that. Let me highlight that in purple. 2, negative 7, 0, and 5. And you're just emphasizing the numbers. So as a refresher, we're going to bring this 2 down. Then we're going to multiply 3 times 2 is 6. We're going to put it in the next place, the next column. And again, you can see this, you can follow along. If you follow this, this is where I'm getting these numbers at as well. Then I'm going to add this column, that's negative 1. And then 3 times negative 1 is negative 3. So you're basically going to multiply, add, multiply, add, multiply, add. That's what you keep doing in each of these columns. So this is negative 3, and then 3 times negative 3 is negative 9. And then add that final column, and I end up with negative 4. Notice the remainder, negative 4, is what I got over here as well. So with a lot less work using synthetic. So again, go through the steps again, bring down the first number, and then multiply, add, multiply, add, multiply, add until you're finished. And then the remainder is negative 4. I also want to remind you, in general, like if I had x to the 4th plus x cubed, and I divided that by x. When I divide by x, notice it literally takes away, you know, from x to the 4th, it becomes x cubed, and from x cubed, it becomes x squared. So it literally takes away one of the exponents. You're subtracting those exponents. Well, likewise, what's left over here, notice I started with x cubed. The original polynomial was x cubed, and I divided by x minus 3. So this 3 literally represents x minus 3. So when I'm literally factoring this out, that's really what I'm doing. When I'm dividing, I'm factoring it out. So this is x minus 3. This is 2x to the 2nd power, because I started with x cubed. So this is negative 1x. This is negative 3. And then you have a remainder of negative 4 out to the side. So if I FOIL this right here, like if I literally FOIL that together or multiply that together and then with the negative 4, it would be the original polynomial that's up here in blue. Okay, so that's a good way to always check it as well. So synthetic division is going to come in very handy as we continue on. This is video number 1 of this lesson 3.3, and be sure to click on video number 2 as well.